I have present I can present research on times transmission of hard information based on the generalized chaotic synchronization model. I am from National University Lviv Polytechnic CAD department. In our research presents a method for transmitting information based on generalized chaotic synchronization is proposed, which is characterized by a sequentially high degree of reliability achieved by changing the characteristics of a signal containing useful information using a noise generator with specified characteristics. It's shown that in the considered methods based on general synchronization, the noise has a structure should that increases the confidentiality of data transmission. The main ideas of the method are illustrated by the example of unidirectional coupled Rosslog systems used as generators of transmitting and receiving devices. The genius of the proposed communication system has been demonstrated by numerical modeling and radio-physical experiments. One of the most important particular implications of the phenomenon of chaotic synchronization is its use for covert transmission of information. In our setting proposes a method of covert transmission of information, which is a modification of our previously proposed method, which provides a complement of traces of modulation of control parameters and ensures a high degree of reliability in its transmission. The method is based on the model of generalized chaotic synchronization, but in the presence of an additional noise source, the presence of feature, as will be shown below, plays a construction role in this case. The use of generalized synchronization model for covert transmission of information opens up a number of new features that are not typical of other types of synchronous behavior, such as full and phase synchronization. First, in contrast to full synchronization, generalized synchronization can be observed in the implementation of various interaction dynamics systems. Secondly, the type of functional depends which is established between the states of interaction system can be very complex, including fractal, which greatly complicates the possibility of obtaining information about the characteristics of the generator. Set the behavior of the generalized synchronization boundary when changing the deuterating of generators differs significantly from the behavior of the boundaries of other known types of synchronous behavior demonstrating abnormal behavior. First, as will be shown below, the noise has little effect on the threshold of the generalized synchronization model. The synchronous model occurs is the unidirectional connected dynamic system in the absence and presence of noise or at close values of the communications first between the systems. The first three advantages of the general synchronization model were poorly taken into account when developing the methods of covert transmission of information on the basis of generalized synchronization, which was mentioned in the introduction. In the scheme of figure 1, we can see the implementation method of covert transmission of information and its method based on the model of generalized chaotic synchronization in presence of noise. First part, that is the transmission device. Second block is noise generator. Three block three-block communication channel, and four-block is a receiving device. After setting, we can see the fragment of temporary implementations of the chaotic signals on information signals. Other variants for signals M from tree and M from TB. Error dependence of error probability on a bit. Have next view. On A is a signal ratio. On B, frame the attention of the signal in the communication channel, and C, from the length of the time interval during which on bits is transmitted. In this figure, illustration of numerical implementation of the method of latent transmission of information on general chaotic synchronization in the presence of noise. Values on this noise we have 10. Information signal M are presented by a simple sequence of binary bits. Signal generated by the transmitting chaotic system on the figure. The signal is still transmitted over the communication channel on C figure. Sorry, C and B figure isn't very good. Sorry. The figure also shows the deterministic information signal after pushing through the low-pass filter. And in the figure 5, we can see the power spectra of the signal generated by the transmitting chaotic system with signal S and transmitted with the communication channel. The figure 6 shows the detect information signal with operation of method of power transmission of information on the model of generalized synchronization in the presence of noise. If the noise generator produced a stochastic signal characterized by an uniform probability density distribution and the intensity of the stochastic signal. The figure 7 shows the detect information signal with the operation of method of power transmission of information based on the model of generalized synchronization in the presence of noise if the characteristics of the noise generator are modulated by sequence on binary bits. While the original information message will still remain inaccessible to it, at the same time, on the receiving side of the communication channels change if in the nature of the noise will remain invisible, and the quality of information transmission will be as high as when changing the signal characteristics of the noise generator with constant characteristics in the absence of such also. Thus, it's possible to improve the method of covert transmission of information based on generalized synchronization in the presence of noise by changing the characteristics of the noise generator by acknowledging false information message which increases the confidentiality of information transmitted by the proposed method. Our research proposed a method of coverage transmission of information based on the model of generalized synchronization in the presence of noise, which overcomes three disadvantages inherent in the known schemes and devices for similar purposes. This method allows users to hide traces of modulation of the control parameters of the information signal, has a high resistance to noise, and eliminates the requirement of identity of the generators on different sides of the communication channel. The efficiency of the method illustrated using a rossless system as sending generators and devices, but at the same time, the method remains operational in the case of using other generators in transmitting and receiving devices capable of demonstration, the model of generalized synchronization. Thank you for attention, and question, please.